Hi everyone, so today we are going to learn how to go ahead and do a one-way ANOVA using Excel. So what I'm comparing in this particular study, and you don't need to know really the specifics of the study, but I want to know the difference between the affirmation, backlash, and control conditions in this study on parent likability. Now, Excel is sort of weird in that in a lot of other data analysis programs, you would code the thing as 1, 2, or 3, depending on what condition participants were in. And then what I could do is I could actually use this condition column to predict this parent likability column. Now, it's not quite so simple in Excel. It's a little bit of a pain here, but what we're going to do is actually, I need to actually create 3 columns here. So I'm going to do column 1, column 2, column 3. Under column 1, I'm going to put all of the data from condition 1, so you can see that that stops right there. By the way, if yours weren't already sorted, you could easily sort this data so that all of the ones are together. So I'm going to just put all of those under the column 1. Then I'm going to grab all of the 2s and put that under column 2. And then I'm going to grab all of the 3s and put that under column 3. So this now, basically what I'm doing is each condition in my study now has a different column in my data file. Now to run this one-way ANOVA, and by the way, we run a one-way ANOVA when there are it's actually a between groups one-way ANOVA in this case, meaning that each of my participants was assigned to one and only one of these 3 groups. So I come up here to data analysis, and if you don't have this data analysis option, it's under the data tab there. If you don't have that, then you can watch my other video on how to actually add that. I don't know why. Oops. I accidentally collapsed my ribbon here. So I'm going to click data analysis. I'm going to do ANOVA for a single factor. And then I just need to select my data here. So I'm going to go ahead, I'm going to go ahead and grab columns 1, 2, and 3. I'm not going to grab that initial one. You just need to say that you grab the labels, and I'm going to drag down to the lowest one. And so I'm just grabbing all of that data, and I'm telling it that it's grouped by columns. So it's grouped by columns. If I did grab those 1, 2, and 3, I'd just click this label in first row option, and then I just tell it where to put my output. And it doesn't really matter where you tell it to put the output. Just grab a big swath of cells there, and then hit OK. So what it's got is we've got column 1, which there were 61 people in. Let's just double check that that's the case. It comes down to row 62, but the 1 up here is taking up one of those. So yeah, we grabbed the right things here. So that's saying that the average in column 1 was 7.55, the average in column 2 was 3.25, and the average in column 3 is 6.28. It also gives us our variance. Now, one thing that you could ask for is standard deviation, because in a lot of results sections you're going to report that, in which case you just do square root equals square root of that. Bam, you got your standard deviation, and then you can just drag that down to the other 3 conditions. Now, a lot of times I like to actually limit if we go up here to home, we can actually decrease the number of decimals here. It makes it a little bit easier to work with. So I'm seeing that my average is 7.55, 3.25, and 6.28. And now I want to know, are these significantly different from one another? And I'm already thinking that probably this 3.25 is going to be different from those other 2. And lo and behold, if we look at our p-value here, it's actually p 2.80 to the negative, or to the 26th. Basically, we got to the negative 26. We got to move that decimal 26 times. So we would say that this is, highly significant there. And our f value is quite large here. The critical value for F would have been 3.05. Actually, in this case, it's 85.43. So we do know that there is at least one significant difference going on between these values. Now, if we wanted to actually know where that significant difference is, we would need to then compare, we'd need to run like post hoc analyses between those specific conditions. So we could just run those post hoc analyses. You could do Bonferroni comparisons, you could do Tukey post hoc comparisons, but for that, really you would need a different software if you really wanted to take that out and run those Bonferroni or Tukey post hoc comparisons to actually compare, group 1 to group 2, group 1 to group 3, and then group 2 to group 3. What I would suggest is if you need to take it out to that step, download and install Jamovi. Check out my other videos on Jamovi, because this would be pretty cumbersome using Excel. It would probably honestly take you less time to download Jamovi and run it that way than it would be to do this by hand in Excel. So, hey, if you have any questions, though, I am always here. Just shoot me a line, and I'm happy to answer them. Otherwise, hey, have a great rest of your day.